So have people heard of vector database? Other than it was talked about 2 minutes ago. Now, if you haven't heard of it, you probably haven't used it, and you probably don't know who we are. So this is me. We had that introduction. Now, when you're making these models and you have a lot of data, previously it was in a database, Postgres, CSV, wherever you had it. It was pretty easy to deal with because it was designed to be dealt by people and computers. But now with the power of deep learning models, we can now work with all kinds of weird, different data, which has its own unique challenges: PDFs, Word documents, images, video, audio. What's cool is we can now take that data, apply a model to it, store it as a really big number in a vector database, and then you can get it back super fast. Why that's important? She talked about semantic search. That is a great use case by itself. But when you're doing something like RAG, or if you want to talk to an LLM, being able to get any data you want that's your data and store it and make it available for instant search means I could build my prompt. So yeah, maybe I'll fine tune some models. Maybe I don't, depending on what it is. The models change every day. There's a new one every day. Do I want to fine tune all these models and pay all that money? I don't. So what's nice here is take your data, make it available in a vector database, and then you could use it against any model and swap out models on demand when you feel like it. You know, like, okay, today I'm trying Llama 3.1, Llama 3.2 came out, Llama 3.2 instruction quantized 2 billion parameter version came out. Let me try that one. So it makes it nice that you don't have to fine tune anything with your data. You take the data, and most of these libraries will grab it from the vector database automatically, format your prompt with it. So if your prompt was like, what is Milvus? Well, we could grab every document that you grabbed from the Milvus repository, any PDFs, any internal data you used and put in the vector database as your context. So now you're sending that context with your prompt, and now the context spaces are huge. So you can put as much in there as you want, but really it usually focuses on the prime bit because our semantic search is powered by those same AI models. So we get you back the same information that they would be looking at. So you give them your version of that information, and that could be proprietary, that could be any information you have, whether that's all the emails at your company, logs, Slack messages, Discord messages, all of that. And what's nice now is it doesn't even have to be that. It could be images. I could search within an image, find your stuff. I've got a cute demo using ghosts. If it was a little cooler in here, I'd have my Ghostbuster stuff on, but it's a little warm in here. So let's look at some real world stuff. So I'm running everything open source, free, and on this laptop. So if things break, it's because I did something dumb. So what's nice is all of this can be done on your laptop or on cheap computers for free, which is awesome. I'm running Ollama, which lets you run your models locally, and it is a very cool little app, and it'll host a lot of different models. Now they're not tiny, but I could fit this on my computer. I probably don't need every model in the world, but these are the ones I've been playing with, and they're pretty good. Gemma is the free version of Gemini. Then I got a couple Llama 3s in there. And Lava's really cool. It's one of the new models that's multimodal, which means I can search text or images and interchange them, which comes in handy for some of the stuff I'm doing. So we import some libraries, and here I'm connecting to Milvus so that Milvus can run in a big cluster somewhere and charge you money, or can run in Docker or Kubernetes, but I'm just gonna run it right on my laptop in a small file right from the notebook. It makes it easy, means I don't have to worry about network, don't have to pay anyone. I run that there. I use one of the newer embeddings. This is one of the clip embeddings that allows you to do multimodal work. And here I have a number of pictures of ghosts on my computer. And I'm just going to go through them all and run the embedding model against them, get them in a nice vector form. And then I create my collection within the database is how we store them. And then I have a query here that lets me search them. We will run that one again. And return back the related image and the name of the file where it is so I could tell what it is. So my query was, if you look up here, I passed in, for my query is the text here, and that is a white floating ghost combined with this image. So it built a hybrid search with the encoding of the text query plus the picture, so that it gets it as close as it can. When this comes in interesting, and this one's running online, you could try it, is you put a picture and you say, make it similar, but give me a different color. So you can tweak your queries by doing a combination of an image and text, which comes out pretty cool. I think that's a pretty cool feature. Now, normally with a vector database, I don't have to put the text in. If I just want to query by an image, I could put up an image and it matches it, which is really cool. But here it matched it against a bunch of different images. And then I'm going to take those images and I'm going to make a panoramic image here. And why I want to do that is I'm going to send this to a model which is running locally on Olama. This is Lava 7B, 7 billion parameters, which doesn't take up too much space. And that's running on my laptop. And it's going to take a look at all those images. And it has the number there. And it's going to rank them, which it thinks is the best result for that, and give me a reason. And then I could print it out. And it gives me, where were we? Too many stuff going on. Okay. It gives me the one that it thinks is the best and shows me the picture. And that looks pretty close. Another thing we could do is I can query on more advanced searches. I want to see a scene in New York City with ghost cats and pumpkins. So it's giving me back the closest ones that match that. And as you can see, that's pretty good, though this is a cat, but you know, it kind of looks like a ghost. It's pretty close. And then I can take that picture and send it to a different model here. Well, I'll send it Lava 7 again to have it describe the image. So I pass in the image and it gives me the text for that. And then I take that text and post that to a Slack channel. And that's all running open models, open source Milvus, all free. And you could do that very easily. Very simple to be able to do a model, generating all of that for you, being able to determine and query against things that are unstructured. I mean, PDFs, text, images, video, audio. If you've got the right model, you can do it. Now, unfortunately, in the world today, there's 1,000 different AI products in the open source and in closed source to do all different pieces. It's kind of easy. I take a couple of images, load them into a vector database, but this goes really deep. So if you're interested, this links to an article where it shows you all the different layers, because there's a lot going on there. But in the future, most people's data is coming from unstructured. Every year this gets higher, because where does stuff happen? Someone uploads images to social media. They chat in Slack. They chat in 50 different chat tools. You send email. You've got text documents everywhere. This is where people want data. Sure, there's all that data we had before. We know how to deal with that. And even the large language models can work with those very easily. But now no one wants just what's in your database. They want to know well, there was a picture of this at this place. I want to know what was in there. Or I want to be able to read the old scans of reports where we lost the original data and get me that data out correctly. So there's a lot of reasons we want to be able to grab that. Fortunately, I don't have to tell you about similarity search because we had that. But this comes up as, can I just use a library? There are Python libraries, there's C++ libraries, Rust libraries that do some vectorization for you. They can encode a model, they could store it, and you could probably get it back, but it's not a database. If anyone's written a data system that just used a CSV as your main thing, you're missing out if you just have, a bunch of data somewhere and you need to use it, especially when you start getting a lot. Once you say, if I grabbed every image that happened today in New York City, try to store that. You're talking millions of things. You'd be surprised how many images, text, PDFs, emails you get very quickly. So to be able to handle that at humongous scale without having to change any code, being able to do all kinds of search and handle all these different models that come out is not trivial. To be able to make sure you're running in disk or in memory, to be able to do different type of vectors. They're not just, everything isn't the same anymore. There's sparse ones that use smaller numbers. Those work for specific type of text. Some that work better for images. Lots of different options there. And of course, at some point, people are going to say, is this data secure? So you need to have security. Otherwise, someone may steal your cat pictures, which would be horrible. Unless they're taking a sticker, it's okay. You saw the RAG part, and RAG really doesn't happen without the vector search there to be able to get you that data, to craft that prompt better, get the right context for you to call any model. What's nice is all open source, and this works with any of the models. So it's not tied to any one platform. You don't have to run on Google. You don't have to run on Amazon or Microsoft or OpenAI or Mistral or Cohere. As you're seeing there's a lot of them, and they all have a couple of awesome models. Do I want to be tied to one of these vendors? Do I want to be able to do this for free anywhere I want? Llama and all these other models are pretty good. So we pick and choose, and we could change this on the fly. Well, you still have all your context in a database you could use anywhere, anytime, and that you own. So you're not giving away your data for one of these giants to train on. You just give them the snippets you need for your thing, or you use your own models on premise. You don't even need a network. Where this comes up is we've worked with NVIDIA to be able to put this on robots, edge devices, and there's a lot going on there, so that they can have everything localized in case they're working in environments that don't have network, or they need to make decisions very quickly. If the robot's going down the street and someone's in front of it, it shouldn't have to call back to the cloud, make a decision, look something up, and then just drive right through you. We want it to be able to act instantly, without guessing or having a big if-then statement in there. I would skip that one. So we built Milvus, and we found out the hard way, this is a hard thing to build because vectors are huge arrays of floating point numbers usually, and to be able to search them quickly, we found out you can't do this in one box. We thought, we'll just make one server, and you just have one big server. How much data are people going to search? I mean, how many images are there on the internet? Not that many, right? Well, we found out some very large companies are like, hey, we have 1 billion vectors we want to work with. Well, that's not fitting on any machine you want to pay for. So we figured out you had to make it cloud native, spread it apart, put it in different nodes, which is difficult for us, but not difficult for people using the open source. What's nice, like I showed you could just install it in a notebook and be ready to go. And if you don't care about billions of rows of data, it doesn't really matter. Again, work with any type of data, pretty easy. And the same code, you just move it over somewhere else, not too hard. By default, these other things out of the box are integrated. So you can just press a button and use anything from Hugging Face, use any PyTorch model. If you're just starting out with coding in AI, LangChain is probably the easiest to get started with. Lots of examples. Pretty simple Python code. And we run anywhere. Again, like I said, I'm running on my laptop here with Ollama, which works pretty well for most of the stuff. Oh, we had a new feature come out. This is things only database people think are cool. So we have a way to show the data in the database, which is not usually that interesting in a vector database, because if you look here, it's numbers. So you want to see a string of 512 binary numbers? No, or 512 floating point numbers? Not too exciting. So we added a visualization here. Oh, it timed out. We'll do it again. So we get our vectorization, and we look at what the database looks inside, which is kind of crazy for some of these. This one's probably too much data in it. I try to show a million things at once. It's probably not smart. Yeah, this is a little easier to show. So we could see what's in each point and then follow it down to things that are similar and then follow it down to the next chain. So this is a little easier to make sense of when I do a search, how are things related? You know, how do I get those results? So I think this is a cool visualization we've added. This is another open source tool that lets us do that. And what's cool is I said you store the data outside. So I'm storing my images in Minio, which is a free open source local version of object storage. It's S3 compatible, which is nice. That means you could use all the S3 APIs behind the scenes. So when I'm loading data, I could just send it up to S3, which is a pretty cool way to do that. In this one, I wanted to see how many different embedding models I could use in one collection. We could do up to 10. So if I want to try different ways of searching things, there are different embedding models, different style. Like S3 is closer to traditional search engines, which do keyword-based matching on something like the BM25 algorithm, which is uses more sparse data. So zeros and ones, again, if you wanted to shrink it down, if you had a corpus of pretty common English text, using something like BM25 makes a very small sparse index, which doesn't take much disk at all. And again, text compresses really well. Those are very common for if you know what the space is, you know what questions you're going to ask. That works out pretty well. But if you're not sure, you could store it as sparse and store it as dense vector and search against both. And then we combine them in a hybrid search so that we get the best of both. So in this one, again, I got ghosts. I live in a Victorian house, so ghost busting is kind of my thing. So in this one, I'm going to take queries from 4 different ways I encoded the same data and then have them ranked based on how important I think each one is, and then it gives me the results back. So you got one that's doing a search using an image, one that's doing this text, a purple flying ghost, and then I'm doing one on the sparse, doing one on the dense, and then we run them all, and then we get the results of the combined 4 queries against the 4, do I have 4 now or 5? 4 different vectors, and I get the results back. And then I could iterate through them, get the best couple, and then I take those and I make a little report on them using, I found you could do Markdown right in Jupyter Notebook, which is kind of cool. But pretty easy to do this stuff. It's, like I said, all runs on the laptop, couple hundred images, couple hundred documents that'll run locally just fine, and the search results are sub-second. No matter what kind of query it is, you're right. Passing an image in to query against hundreds of other images comes back nearly instantly, and that's without using any GPU or fancy indexing. We're probably now out of time. Okay. Thanks, everyone, for coming. Grab some free stickers.